This is my 100th video. Thanks for the support and motivation. I got nearly 550 plus subscribers and near to reaching 600. And all the topics what we are covering in machine learning, if you are really interested to recall, you can watch the previous videos. So in this video I plan to explain about KNN algorithm, K nearest neighbor algorithm. So when we are coming to KNN algorithm, it will identify the nearest neighbors and it will just make a segregation between classes. So for example, in our current program we plan to see on two different classes in our data set. So before going to that, I will open the data set what we are having in the data set. So let's look into the data set so that you can able to get the idea. So our data set, you can able to see there are three columns in the data set. So the first column what you are seeing here, that is said to be age, the second column is said to be estimated salary, and the third column is said to be whether the customer will purchase or not. Okay, so we may use the same data set for the previous algorithms. For KNN also we are using the same data set. So what and all the detail we are gathering from the data set, whether the age group or the age group we are having, whether the age group decided here in the first column, the second column what the salary taken by the age group. For example, he is 32 years old and he is getting 1,50,000 salary, and 25 years old 33,000 salary. So this is the details they are fetched. And the last column what we are having is whether the concerned person purchased the particular product or not. So the product we are selling and that product is purchased by the concerned person or not. If it is 1, he is purchased the product, otherwise we are mentioning as 0. Okay. So for example, when we are taking this as a mall data set, so mall data set, who and all purchased the concerned product. So when there is a car placed in the mall, so how many of them purchased the car? So whether the person 1 purchased the car or not, whether the person 2 purchased the car or not, that we can able to decide here. Okay, so the person having 1,50,000 salary, he is purchased this car, and then the person who is having 52,000 salary, he is not purchased the car. Okay, so these and all the identification we are getting with use of the data set. So let's go for the coding part now. So with use of this understanding we will go for the code. Let's see the code. So here we are having three important packages. Those packages are used in all the programmings whatever we are having in the previous algorithms. So NumPy as NP, NumPy mean by numerical Python, that is used to do the mathematical calculation in Python programming. Next to that we are using Matplotlib. Matplotlib is a main package that is used to plot the graphs. We are plotting scatter graph, bar graph, okay, pie chart, all these things we plan to plot in the machine learning algorithms, because machine learning algorithms input is said to be the data sets, whatever the data sets we are getting from the open source, or you are preparing a data set and you are giving us input for the machine learning model. Next to that, what the output is in the form of charts. Okay, what is the analysis? For example, 2010, 2011, 2012 until 2022 we are making the comparative analysis of the business model, so that we have to put bar graphs. Okay, in the form of doing our classification work, we have to do a scatter graph. Okay, so that we can able to make the class 1 class 2 segregation in our graph model. Okay, so for this purpose we have to go for Matplotlib. Okay, Matplotlib.pyplot is a very important package in machine learning model, and we are using PLT as reference. In spite of using Matplotlib.pyplot every time, we have to use PLT as a reference. Okay, next to that we are using Pandas package. Pandas is a major package to handle the CSV file. Whenever we are using our input in the form of CSV or Excel or PDF, that has to be handled and that has to be converted in the form of data frames. For that reason we are using Pandas package. Okay, so next to that we are just importing our data set. So for importing our data set we are just using read_CSV. So pd.read_CSV we are using because PD is the reference for pandas package. Dot read underscore CSV is a predefined method inside pandas package that we are using, and we are just reading our CSV file. Okay. So that CSV file what we are reading, what I shown there, that will be converted in the form of data frames. You can able to see the data set is a variable that's in the form of data frame data type. Okay, what I opened and shown you, that is a data frame model. Okay, data frame data type model. Okay, so there what we are doing next, we are converting X and Y. So X and Y we are converting with use of iLog. So I index locator we will tell. So iLog we will make it. So colon comma colon minus 1 dot values. That is mean by, if we are having 3 rows, we are having 3 columns in our data set. Among 3 columns, first 2 columns will be converted as X, and the last column what we are having, that will be put in Y. So that colon comma colon minus 1 defines that excluding the last column, the first 2 columns will be stored in X. Okay, the first 2 columns will be stored in X. What is mean by Y? Only the last column, colon comma minus 1 mean by only the last column will be stored in Y. Okay, so let's see the X and Y in our execution part. So X is set to be only the first 2 columns. You can able to see the output here. This is X actually. You can able to see the X values. The age and the estimated salary will be stored in X. Okay, let's see the Y value. What is the Y value stored here? So Y value is only the last column what we are having in the data set. So that is set to be whether the person will buy the product or not, or purchase the product or not. Okay, so 0 mean by not purchased, 1 mean by purchased. Okay, so let's move for the next one. What is the next one? We are having the data set is splitted into training set and test set. So what the necessity of training set and test set? Whenever you are designing a machine learning model, some data set has to be given, and that with use of the data set we have to train the model. Train the model mean by we are giving knowledge to the machine learning model. With use of that knowledge it will predict the testing set. So testing set and training set we are splitting in the entire data set. So from our given understanding, 0.25, that is mean by 25% of the data set will be goes for training set. So after splitting training set and testing set, we are having totally 400 rows on our data set, so that you can able to see 300 rows will go for training set and remaining 100 rows will go for testing set. So among 400, 25% mean by 100 rows. So 100 rows will be go for testing set. Okay, so let's open this training set. You can able to see nearly 300 rows will be there in the training set. Okay, and remaining rows will be go for testing set. Okay, so next to that we are doing standard scalar. So when you are seeing the data set, initial data set, whatever the data set you've seen, the values are not in proper way. So you can able to see 76,000, 50,000, 1,50,000, and here in this first row 26, 35, all these values are there. There is no good variation between one value to another value, so that we have to make a good variation between the values. For that reason we have to use the algorithm named standard scalar. So standard scalar algorithm is very much useful to convert the given value in the form of decimal numbers. So the decimal numbers in the range of 0 to 1, so that it will just use to give a better accuracy when you are feeding that output of standard scalar, that feature scaling output to the machine learning algorithm, mean by classification algorithm or a clustering algorithm. Okay, so let's see the execution of this. So when I am opening xtrain, so you can able to see previously we are having values. Now the values are converted in the form of decimal numbers. So these decimal numbers will be given as input to the classification algorithm. Okay, so next to this what we are doing, we are applying the KNN algorithm. So KNN algorithm will be applied. So KNN algorithm will be taken from sklearn.neighbors. sklearn.neighbors is the base package. From that we are taking the k nearest k neighbors classifier package. So with use of that we are creating 5 members actually, 5 neighbors we are creating. With use of 5 neighbors we are using different method. Mean by the neighbor, whatever the distance formula we are calculating. There are different distance formula. In that, Minkowski is a one type of formula. With use of that formula, we are calculating the distance between one node to the another node. Okay. So for example, which is least distance from the particular node, so that class it will merge with. Okay. For example, I am having two different classes. There is a point here. So class 1, the distance is 15. I am telling, for example, from class 2 the distance is 25. So that particular point will be merged with class 1 because the class 1 distance is very less because we are having 15. Okay. So this particular information you will see in the first part. So I hope you understand from that. So here next to that we are just having the prediction ypred. So ypred is the predicted value and ytest is the actual value. So this is the predicted value, what the prediction by the KNN algorithm, and ytest is the actual value. So by comparing this two, we will get the accuracy. This is the actual value of prediction, this is the predicted value. So let's see. With this understanding, we will move for generating the confusion matrix. So confusion matrix mean by the diagonal values are correctly predicted in confusion matrix. So in KNN algorithm, how many values are correctly predicted? As I told, we are having 100 as a testing set. Among 100, we are having nearly 64 plus 29 are correctly predicted, remaining are wrongly predicted. So 4 plus 3, that is 7 are wrongly predicted, 93 are correctly predicted. So our accuracy will be 93% accuracy. Okay. So let's see the accuracy score here. So you can able to see the accuracy score. So the accuracy score is defined here, that is said to be 93%. You can able to see in the console window. Okay. I pre-executed everything because while executing on time, real time, it taking execution time. So there is a delay in showing the output. For that reason, I executed previously for showing you the graph. So graph is very important because for the previous lecture I am unable to see show the graph to you. So you can able to see the graph for KNN. So the KNN graph is totally looking very beautiful. So when you are seeing linear regression, a single line will come. So it may not be a correctly classified thing. Lot of classification results will be not proper. But in KNN, we are getting a proper classification. You can able to see the classification is going like this, and the red class and the green class is classified properly. Okay, there is only very few wrongly classified things are there. This is for training set. When we are using testing set execution, you can able to see only 7 nodes are wrongly predicted. Remaining 93 are correctly predicted among 100. Okay. So this is what the understanding you should have in KNN. I hope you understand this particular algorithm. Okay. So previously in the starting part, I explained about the algorithm clearly. Then we are moving to the coding part. Okay. So I hope you understand. Share, support and subscribe. Subscribe the thing. I am very happy. I am thanking you all because you motivated me and making me to upload this 100th video. Thank you very much. Thank you all.